Okay, let's give you guys some examples. So in this video, we're going to try and work out the area trapped in between these two graphs. So r equals 3 is this circle where the radius is always equal to 3, and the blue graph is given by this. So to work out this area here, our normal routine would be to start with angle being 0, and then sum up all these sectors. We would sum up all the sectors here. So our normal routine would be to sum this up, 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 and then work our way around here, and then sum this up, 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 and then eventually that will then give us this whole area here. So if you look at this one particular sector here, let's call this angle here d theta. So let's say this angle here is d theta. So our normal routine would be to work out this whole sector here. So that whole sector would be given by a half, let's call it a half, and then let's say this is r2 here, a half r2 squared d theta. So this whole block here gives us the area of the whole sector here. But then we've got to take away the inner sector. So take away the inner sector, take away this sector here. So that would be a half r, let's say this is r1 here, a half r1 squared d theta. So this thing here, this block here, is the area of this inner sector. So we would get the outer sector, take away the inner sector. So what's left is this bit here. It's what we want, and we want to sum up everything. So if you look at this, you can factor out the half here. Factor out the half. That will then give you this, and then, well, from here, I hope you can see that you can jump to here. So we need to sum up all the sectors. So we will need, if you look at this here, in order for us to sum up everything, we will need to locate where we need to integrate it from where to where. So basically we need to find out this point here, and we need to find out this point here. So our next step is to locate where we need to integrate it from where to where, meaning we need to find out these 2 points, because we need to sum up everything here, and then well basically we need to sum it up. We need to sum everything up from here to here. So we need to locate this point, and we need to locate this point. So in order for us to locate these 2 points, well, if you look at those 2 points, the 2 radii will be the same. So set this to equal this, and then find theta where the 2 radii will equal each other. So set this to equal this. So that will then take you to here. So theta, rearrange it. So theta, well, take away 2 from both sides. That will then give you 1, and then divided by 2. That will then give you half equals cos theta. Well, from here you should visualize this famous triangle where the base is 1 and the hypotenuse is 2. Well, whenever you have this angle here, this is really 60 degrees. Well, 60 degrees is really pi over 3. So cos of pi, well, if you look at this, well, when you get to here, remember this famous triangle where you have base of 1, this of 2. So the angle here is 60 degrees. So 60 degrees is like pi over 3. So if you look at this, cos the angle pi over 3 equals a half. So if you look at this, you can see that the angle must be pi over 3. So the angle here is pi over 3. So if so the angle here is pi over 3. Hang on. So this angle here is pi over 3. So we could well, to work out this area here, remember that theta always moves in an anti-clockwise direction, but we want this bit here, so we would need to integrate it from the angle here. So rather than working all the way around here like this, well, if this angle here is pi over 3, then this angle here must be negative pi over 3. So we can integrate it. We can integrate it from negative pi over 3. So we need to integrate it. So it starts from negative pi over 3, and then we will need to integrate it to positive pi over 3. Okay, so once we've got pi over 3, we will need to integrate it from negative pi over 3 to positive pi over 3. But by the way, earlier we had a half here, but it's a constant. We can take it out. So we would need to integrate it from negative pi over 3 to pi over 3. But if you look at this here, so rather than integrating it from negative pi over 3, we could just integrate it from 0 to pi over 3, and then later times it by 2. So rather than integrating it from negative pi over 2, just do it from 0 to pi over so just do it from 0 to pi over 3, and then later on we can multiply it by 2 because it's symmetrical down here. Well, hang on. So we were here, integrated from here to here. So the whole area is given by this, but then we're going to integrate it, and then later. Well, we would need to do this. Let's just integrate it from 0 to pi over 3, and then times 2, and then merge this 2 with this. So these two will cancel each other out, giving you this. So the whole area is given by this. I will continue in the next video. So we're currently here at the moment. Okay.